Hi everyone, welcome to this video. In this video, we are going to see about what is Apache Spark and what are the limitations of Apache Hadoop and how Spark will overcome these limitations and some real-time use cases on Spark. So let's get started. According to Apache, Spark is a fast and general engine for large-scale data processing. And we know even Hadoop falls under the same category. Hadoop is a distributed storage as well as processing platform. When we have such a powerful platform in existence, why again we need to think of implementing one more additional component into the big data stack? Let us see if Hadoop is having any limitations. These are the primary limitations of Hadoop. When it comes to interactive queries or iterative queries, Hadoop is based upon the Mapreduce processing framework, which is extremely slow because of its nature to write everything into HDFS. Let us see how the Mapreduce is going to process the data at a very high level. Consider this is a Hadoop cluster and we have an input file to be processed. So this is the input file, and Hadoop is having a storage layer called HDFS, and this input file will be loaded into HDFS. And to process this file, let us consider two Mapreduce jobs are running. So I can call this as Mapreduce job 1, MRJ1, and let us have one more MRJ2. And the first Mapreduce job will read this file from HDFS. It will process it, and all the intermediate data which is coming from this Mapreduce job 1 are again pushed into HDFS. So this is my intermediate data, and this intermediate data is again read by the second Mapreduce job, and the final output which is coming from this Mapreduce job 2 we can write back to the HDFS. So we can consider this as our final output. If you see here clearly, most of the time the Mapreduce applications are writing to HDFS and reading from HDFS. So most of the time they are spending on I/O, that to HDFS I/O, which is more like a disk I/O. And we know disk I/O is a very costly operation. It is going to take a lot of time. Without compromising the durability and the availability of the Hadoop platform, if we can include a better processing layer instead of Mapreduce, that is where exactly Apache Spark is going to come. And let us see the same scenario in Spark, how the things are processed. Let us consider a Spark cluster, and I want to process an input file. This is the input, and in Spark there are two processing components, so I can call this as my processing component. So in the processing component I have one component called as driver, and we have other component called as executors. So in this scenario I am taking two executors. I'm calling this as executor 1 and this one as executor 2. And Spark is having a flexibility to use in-memory as a storage mechanism. So let us consider the in-memory of the entire cluster is the storage for Apache Spark. So this is the storage. Now if I want to process this input file, the very first thing what Spark will do, the driver will read this input and it will connect to the executor, and one of the executor will create this particular input file and stores that into the in memory in the form of a RDD. So I will call this as RDD. RDD is for Resilient Distributed Dataset. And executor 2, which wants to process this RDD, will read it, it will process, and the final result, which is coming from the executor 2, again can be pushed back to the driver, and the driver can write the final output to a storage layer like HDFS or a Hive table or any other NoSQL store. So it can be either HDFS, or it can be Hive, or it can be HBase, or it can be any other storage layer. And if you compare the way the Mapreduce is processing and the way Spark is processing, in Spark most of the data is processed in memory, it is loaded in memory. So we can eliminate the unnecessary overhead of writing the data into HDFS and reading the intermediate data back from HDFS. Not only this, there are a lot more reasons why Spark is preferred over any other distributed storage platforms. And if you see the benchmarking test what I have done over a file size of 1.56 GB, and we ran a word count application on Mapreduce, which is taking 11 minutes and 1 second, then the same application is rewritten in Spark, which is taking 2 minutes and 6 seconds. These are the main advantages of Spark, and Spark is almost 100 times faster when we are running in memory and 10 times faster over disk. And Spark is having very beautiful API in all languages like Java, Scala, Python and R, which facilitates the rapid development and no need to write a lengthy boilerplate codes. Most of the thing the Spark API will take care. And coming to the ease of deployment, we can deploy Spark clusters with the help of Mesos or with the help of Yarn, and we can deploy even in standalone mode or even in the local mode by having the storage components like HDFS and S3. And Spark is having a very beautiful unified stack for processing batch applications, streaming applications, and interactive applications. When it comes to the batch processing, we can leverage Spark SQL, where we can get the data from n number of sources. They can be structured sources or they can be unstructured sources. We can get the data and we can create structure on top of it and we can process the data. And when it comes to the Spark streaming, which is having support to get the data from real-time sources like Twitter, Facebook, or Kafka topics, or JMS queues, we can get the data, connect to the Spark application, and process the data in almost near real time. Spark supports machine learning library, where we can do a lot of machine learning analysis or classification or recommender systems. And when it comes to the graph processing, if you want to create graphs and traverse the graphs and for your different use cases, so Spark is also providing a very beautiful API for graph processing. And all these 4 modules are based upon the core module called as Apache Spark. There are quite a good number of use cases for Spark. I have listed few of them. One of the use case is to detect of fraudulent transactions in the financial industry, almost in near real time. In this type of scenarios, the application should support to capture the data from different sources in real time and to process the data in near real time. The data volumes can be spread across few kilobytes to few gigabytes. This type of huge potential, Spark is able to process the data at a very, very high rate when compared to Mapreduce. That is the reason why almost all financial industry are implementing Spark into their existing architectures. And eBay, which is the classical example, every day it is processing 100 terabytes of data spread across 3000 nodes of Spark cluster to give better customer experience and to target offers for the customers. And there is another application called MyFitnessPal, which recommends to its users healthy food habits and food items. It is having a very huge customer base of 80 millions, and all the users, they will provide feedback to this application, and they want to clean the data, they want to pre-process the data, they want to finally apply the machine learning stuff on the data to recommend good products to its users. So over a span of 2.5 terabytes on a daily basis, MyFitnessPal is able to do extremely well by including Apache Spark into their architecture. Like that, we have so many use cases, and we are going to see when we are actually learning the course. I hope this video is very much useful for you. Thanks for watching.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.